The deep night sky is a canvas of quiet majesty. You look up and see the stars, a billion tiny pinpricks of light. And you ask the oldest question in human history: where did all this come from? In that moment, you are standing alongside philosophers and scientists throughout time. You're not just staring at space. You're staring at time zero. What happened there? Was it a single, explosive beginning? Or is our existence simply one moment in an infinite cosmic breath? Today, we're going to step into the minds of the experts and explore 5 radical theories for the creatio and of everything, starting with the one that changed everything. The moment of creation, the Big Bang. For most of the 20th century, the universe was assumed to be eternal and static. Then, in the 1920s, astronomer Edwin Hubble looked through his telescope. He didn't just see distant galaxies. He saw them sprinting away from us. Imagine you're at the finish line of a marathon. Every runner is moving away, and the one farthest away is moving the fastest. That's what Hubble saw, and he thought, if everything is moving apart now, it must have been closer together in the past. This realization led to the Big Bang Theory. The core idea is simple yet mind-bending. All the matter, energy, and space-time of the observable universe was once packed into an infinitely hot, infinitely dense point of singularity. Then, about 13.8 billion years ago, space itself started to expand. This wasn't an explosion in space. It was the expansion of space itself, but the strongest evidence came decades later. In 1964, two engineers, Arno Penzias and Robert Wilson, were testing a new microwave antenna. They kept detecting a persistent, faint hiss, a constant, annoying static that came from every direction in the sky. They cleaned the antenna, they chased away the pigeons nesting in it, but the static remained. Penzias later described the noise, saying it was like a dull roar, but it never let up. That dull roar turned out to be the faint thermal energy left over from the Big Bang itself, the cosmic microwave background CMB. This ancient light, the universe's baby picture, is the powerful evidence that makes the Big Bang the leading cosmological model today. A universe without end, the steady-state theory in it. Everyone liked the idea of a universe with a distinct birthday. It felt too much like a beginning and a forced end. This doubt led to the steady-state theory, championed by scientists like Fred Hoyle. Hoyle argued, why can't the universe just be? He agreed with the expansion, but rejected the single beginning. In his theory, the universe is eternal and unchanging on the largest scales. As space expands, new matter, hydrogen atoms, perhaps is spontaneously and continuously created to fill the gaps. The density of the cosmos, therefore, remains constant. Hoyle and his colleagues weren't wrong about the expansion, but their theory completely collapsed when the Big Bang's key evidence, the CMB, was discovered. A universe that had always looked the same could not possibly have such a massive, universal remnant of a hot, initial state. The CMB was the final nail in the coffin for steady state. The cosmic heartbeat, the oscillating universe. See, if the universe had a beginning, what about its end? The oscillating or cyclic universe theory was an early attempt to answer that. It proposes an endless cycle. Big Bang, expansion begins. Expansion, the universe grows outward. Big crunch, gravity eventually halts the expansion and pulls everything back together into a singularity. Big bounce, the crunch triggers a new Big Bang. And the cycle repeats. You can picture the entire cosmos as a giant lung, perpetually inhaling and exhaling. The doubt with this theory, however, became clear with the discovery of dark energy. Astronomers found that the universe's expansion isn't slowing down due to gravity. It's actually speeding up. Dark energy is pushing everything apart so hard that cosmologists are now thinking, there's no way this thing is coming back. The predicted big crunch is unlikely to ever happen. Beyond our bubble, the multiverse and ekpyrotic models, failure of the simple oscillating model hasn't killed the idea of cycles. It's just made them more extreme. This brings us to the more modern, speculative theories that live on the edge of physics. Rooted in concepts like string theory, the multiverse hypothesis, eternal inflation. This idea suggests that our universe is just one soap bubble in an infinite, frothing bath. It comes from an extension of the Big Bang called inflation. If inflation, the rapid expansion right after time zero, didn't end everywhere at once, it could continue forever in some regions, birthing countless pocket universes in the process. Imagine a pot of water on the stove. The bubbles that form are the new universes. They pop up constantly, each one a self-contained cosmos with its own set of physical laws, existing forever outside our ability to ever see or measure them. You exist here, but out there, infinity is unfolding again and again. Cyclic, ekpyrotic models. This is the updated, string theory version of the Big Bounce. It replaces the singularity with the giant, three-dimensional membranes or brains living in a higher dimensional space. Our universe is one of these brains. The theory suggests that these two giant brains collide periodically. This cataclysmic, gravitational slap together generates the immense heat and energy we call the Big Bang, avoiding a true singularity altogether. After the collision, the brains separate, they cool down, and then, after trillions of years, they come back for another dramatic cosmic fender bender. It's an endless, eternal cycle powered by a vast, silent, extra-dimensional drumbeat, from the explosive dawn of the Big Bang to the silent, eternal foam of the multiverse. These theories are humanity's best attempt to put a frame around forever. While the Big Bang is supported by the most rigorous evidence, the journey to understand time zero is far from over. New observations about dark matter and dark energy keep changing the story, pushing the boundaries of Wink. Does the idea of an endless cosmic cycle bring you comfort? Or does the thought of infinite universes make your head spin? Let us know in the comments below. And if you enjoyed stepping into the world of cosmic beginnings, please hit that like button and subscribe for more deep dives into the secrets of the cosmos.